Okay, reflect the triangle in the line y equals x. Now, you might be wondering, where's this line y equals x? Well, you've got to draw the line y equals x first before you reflect it, okay? And y equals x is quite easy to draw, okay? It's a diagonal line, right? It goes through the diagonals, of the square here, okay? So it goes through like that. And, what I like to do before I draw it, I like to put a few points down so I can follow it with my ruler, okay? And I'm choosing these points because, if you notice, here I got x is 1, y is 1. X is 4, y is 4. X is 5, y is 5, okay? X minus 2, y is minus 2. So you notice the x and y values are the same because that's what it is, isn't it? Y is equal to x, okay? That's the line. So I'm going to draw this diagonal in to get the mirror line, okay? That's your mirror, that's what you're reflecting in. And when you reflect, what you're going to do is focus on the corner points of the shape, okay? And with the corner points of the shape, you then measure, you see how far it is to the mirror, and then you go back the same distance. Now this particular point here is actually on the mirror, so its reflection will also be on the mirror, so it stays where it is. When it comes to the other 2 points, in terms of the distance to the mirror, you've got to sort of look in terms of diagonals, right? Because it's a diagonal line you're reflecting in, you've got to look how far it is in terms of how many diagonals. You've got 1 diagonal there, so you go back 1 diagonal. So we end up being here, that point. This one, you're going to go across 1 diagonal, 2 diagonals and a half. 2.5 diagonals. Remember to go along the diagonals, okay, of the squares. 1, 2, 2.5. So you go back half, 1, and another 1. So you end up here. Okay. So you can see then my 3 points. And all I've got to do then is join those 3 points up with a ruler. Of course, I'm using a pen, so it's nice and clear on the video. Use a pencil in the exam, so you can rub it out if you make a mistake, and then it's reflected. Okay. Part B then says translate the triangle S using the column vector -5, -4. Now column vector, right, when it says particularly then translate means to shift the shape, okay? You don't make it bigger, you don't make it smaller, you don't rotate it, you don't reflect it, you shift it, you move it, okay? So it ends up looking exactly the same but somewhere else, okay? Now here it says -5, -4. The top number tells you how many you've got to move along the x-axis, okay? The bottom number tells you how many you've got to move along the y-axis, okay? So it's like coordinates, but it's sort of done in a vertical form. So -5 means you've got to go back 5, -4 means you've got to go down 4. So if I, again, choose a corner point, go back 5, 1, 2, 3, 4, 5, and then down 4, 1, 2, 3, 4. We end up there. That's where the translation is. This then, back 5, 1, 2, 3, 4, 5, down 4, 1, 2, 3, 4. Okay, so we end up here. Now you can do this as well. Back 5, down 4. Of course, it's going to be there because the shape is going to look exactly the same. Okay. Sometimes in the question they ask us to label it a different letter, but they don't here. They just say translate. Okay, and we're done. So it looks exactly the same, doesn't it? It's just been shifted. That's what translate means. Okay, and then it says write down the column vector that will reverse the translation in part 1. So basically, what if we wanted to take this back? You do the opposite of this, right? Now what I mean by the opposite, instead of going back 5 along the x-axis like we did, we're going to go forward 5, and instead of going down 4, we're going to go up 4. So the reverse column vector will be exactly the same numbers, but positive, okay?